Thank you. So I hope you can hear me well. If not, then please wave. So thanks a lot for the invitation and also for organizing this event. I'm quite excited to see what's happening and also to interact with you and chat with you over the day, since I don't know very much the community in Barcelona after all, so this would be nice. All right, so yes, as Gemma was saying, I'm interested in dialogue, in linguistic interaction. Okay, now this is working. So how we use language in conversation for interaction and so on. And I'm interested in how this happens at two different levels. On the one hand, the agent level, where what we try to do is to model how an agent talks to another one-to-one, right? So this is what I'm calling here local dialogue interaction, agent modeling. But I'm also interested in how we use language in interaction at a more global level. So how language is shaped by how it is being used in communities via interaction. And today I want to tell you a little bit about some of my current research using deep learning, along these two lines, okay? So just to give you a little bit of a glimpse of what is it that my group is doing along these two lines when it comes to using deep learning in particular. And I will start with the agent level, where we try to model an agent that takes part in conversation. So as many of you will be aware, the first steps in modeling dialogue using deep learning methods, end-to-end methods, consisted in using sequence-to-sequence models in modeling dialogue as a sequence-to-sequence problem, right? This happened a couple of years ago. And basically here the idea is that we can model chit-chat dialogue by first encoding the dialogue history, what has happened in the context of the dialogue, using some encoder, such an LSTM-based encoder, and then we use this to predict, to generate what happens next, how the agent contributes to the conversation and produces the next turn, right? So yeah, this in a way was a very beautiful, simple idea. We can treat dialogue as if it was a sequence-to-sequence model. We can train this using lots and lots of conversational data to make this prediction. And it's nice in the sense that we are learning from experience, right? So we are doing it end-to-end, and we just learn from what is out there, what's in the conversations that we are observing. But of course, we've also seen in the last few years that this has several drawbacks. And for example, just to mention a few, in the end, if we use this kind of methods, we just are limited to learning surface patterns, right? So patterns that are present in the surface language of this chit-chat dialogue data that we are learning for. And we know, of course, that dialogue is not only that there is intention, right? So we want to recognize the intents of the speakers, we want to recognize intentions of the speakers, there is a speaker meaning, etc. And there is not a one-to-one relationship between the surface forms and the intended meaning. So this is going to be a setup that is not so great for capturing these kind of things, which are the most interesting in dialogue. And on top of that, also, it is difficult to evaluate these systems because we know that it is very open-ended what we can say in a dialogue, right? Or for how are we going to evaluate this? This is just to mention some of the issues with this. But of course, there were also some exciting aspects, right? Like what I said, that we are learning just from observing data. We don't have any internal representations that we have to model beforehand and take for granted, right? But all right, so when I started to use some deep learning methods for tackling dialogue, then I wanted to move away from this initial idea, and I was excited to look at visually grounded task-oriented dialogue. And now I'm actually going to move a little bit into the multimodal terrain, so I hope you don't mind that we don't do only language. Right, so why I think that this is more interesting and more suitable to study questions in dialogue that are a bit more exciting? Well, because when we have a task, and this is well known in dialogue research, right? So when we have a task, this is a way of narrowing down what are the relevant goals and intentions of the speakers, right? So this constrains a bit what this is about. And of course, on the other hand, if we have a particular task that the dialogue agents are trying to achieve, then we also have a cleaner way for evaluating. At least we can look at whether the task is achieved or not. And if there is a task, then there are more chances also to ground the language in some sort of external reality. One possibility is, for example, to ground this task and the linguistic interaction into some perceptual visual environment. You can also do that by using some databases or so, right? But I think that these elements gives us more aspects that, that make the dialogue a little bit more interesting to study, right? And we can try to do this still using an end-to-end architecture where we are learning from experience. So as an initial, this is not reacting very well. So as an initial testbed to study this, we are using the guess what game. And then of course, what happens here is that we go back to very simple dialogues, right? So the dialogues are extremely simplistic. They are almost non-dialogues. But let's try to get started with something, right? Where we keep the end-to-end aspect and we still have these constraints that come from the task. So this is, some of you may know this data set, right? So this is a data set that was created a couple of years ago by Han de Vries and collaborators. And this is a task where there are two agents. One is a questioner agent, the other one is an oracle and an answerer. And the questioner has to identify a particular target object that is known to the oracle agent. And this is done by asking a set of polar questions, where the only possible answer is yes or no. And so the questioner has to decide what questions to ask to be able to finally pinpoint what's the target referent here. Okay, so that's the task. We want to model this, and we are interested in modeling the questioner agent, which is slightly more interesting. So this task, this guess what task, has been modeled by the authors, the creators of the data set, in a rather particular way. So this has been modeled typically as 3 independent tasks. So if you think about the guess what task in general, you could just break this down and say what kind of tasks are involved here. So one is the task of generating questions. The other one is the task of answering questions. This is the oracle. And then the other one is the task of picking the referent, right? So guessing the referent, right? And this is indeed how it has been modeled in the literature, how the baseline models work, like really separating this task as independent machine learning tasks that can be learned separately, right? And I will not go into the details, of course, but so the question generator can just be a decoder LSTM that is conditioned on the visual information and also on the answers that are received from the oracle. The guesser is an encoder LSTM that then, together with the visual information, ends up providing a probability distribution over the possible target object, of the candidate objects. And then finally, the oracle is just a simple classifier that takes the current question and information about the target object and provides an answer as if it was a class, right? So these are the type of baseline models that have been put forward in the literature. And of course, this one, the two here correspond to the questioner agent, but this has been modeled in a disjoint way, right? So we wanted to try to make some progress into this, and I was quite unsatisfied with this. And our idea was, let's try to model the agent, the questioner agent, and try to model what are the tasks that this agent is faced with in the dialogue jointly, rather than as disjoint machine learning tasks. So yeah, so this is what we've been working on recently, on learning this agent that interacts by putting together different abilities at the same time. So just to give you an idea of how this works, so we have, so this is a common agent that does the two tasks, right? So we encode the context, we encode the linguistic information and the visual information that is available to the agent, right? So this ends up giving us what we are calling a multimodal dialogue state, right? So the final layer of this encoder, we consider it a representation of the current dialogue state, which includes multimodal information, right? And then, importantly, the parameters in this encoder are updated jointly by the two tasks that the agent is facing, right? So on the other hand, on the one hand, the agent needs to keep asking questions, right? And on the other hand, the agent needs to guess what is the target object, okay? So the modules here, these asking and guessing modules, they are very similar to the original ones where we have them independently, but here, this is being optimized jointly, so we have this grounded multimodal dialogue state that is optimized in a multitask learning setup, okay? And I think that this gives, my impression is that this addresses some fundamental issues that were present with the previous architectures of this agent, right? So when we have this architecture, basically, you can see of the top part here as a sequence-to-sequence model, right? A sequence that includes multimodal information into the generation of a question, of another sequence, right? So we have a sequence-to-sequence models with an additional objective that is influencing how the question generation is also working, right? So the presence of this joint architecture also allows us to use other type of learning mechanisms, what we call a cooperative learning mechanism, which means that the two modules here, the two tasks that the agent is facing, can kind of adapt to each other, right? So the two modules here can adapt to each other by using additional generated dialogues. I will not go into the details into this. And this can be seen as an alternative to reinforcement learning. So reinforcement learning, I forgot to mention before, is something that has also been applied to the baseline architecture, right? So the baseline architecture has used reinforcement learning. With this joint architecture, we can tackle some of these issues by using other methods that are a bit computationally less expensive. So when we look at how these models do in terms of task success, so how successful is this dialogue agent into asking questions that lead it to pick up the right referent, right? So that this is what task success is, how often we can, by interacting in the dialogue, pick up the right referent. So we know from the literature that the state-of-the-art results, which are around a bit below 60%, if I'm not mistaken, right, have been achieved with this kind of disjoint architecture and the help of deep learning. And the help of reinforcement learning, okay? Right? So what happens when we put together our architecture that has a joint agent that faces different tasks? So when it comes to task success, we achieve results that are comparable, right? I'm saying comparable because depending on some setups of the hyperparameters, sometimes it's higher, sometimes it is lower. So the results at the level of task success are comparable. Now, I told you at the beginning, I think that it makes sense to move from chit-chat, sec-to-sec models of dialogue into something that is task-oriented, because this helps us to constrain the goals and the intentions of the speakers, and it helps us with the evaluation, right? So we can use task success for evaluation. The problem is that a lot of people that are working on task-oriented dialogue then only focus on task success, right? So all we do is to look at how well the task success is, and we just get a number on that, and we don't do anything else, right? So another aspect that we wanted to focus on here was, okay, let's try maybe to look at the dialogues that are generated by these agents, right? Because that was the goal that we started with, to develop agents that actually can talk, that actually can hold the dialogue. So we wanted to go also beyond task success and to try to come up with some measures that analyze a little bit more the linguistic quality of the dialogues that are being generated by these agents, okay? And so we've come up with a set of measures. Of course, these dialogues are very simple, so the measures are not so exciting. But we come up with measures that, for example, measure the lexical diversity of the language that is being used, or the diversity of questions that are being used, or also, for example, the type of strategy that the agent is employing in selecting a series of questions, depending on how the dialogue goes, right? And so, So when we analyze this, then we see that actually the models, even though at the level of task success they look very comparable, they actually generate very different types of dialogues, right? So the agents generate very different types of dialogues. And so here you have an example. So this is, you can see the image, you can see the target referent in green. And so the first dialogue is the one where the humans are playing, right? The gold standard dialogue. And then the one in the middle is the one for this particular image played by the agent that has the joint architecture with the multitask learning setup, plus this idea of cooperative learning that I didn't explain very much. And then you can see here the same dialogue for the model that uses the baseline architecture, which is this joint plus some reinforcement learning on top of it, right? And you can see that the dialogues are rather different, right? In this case, if I'm not mistaken, all of them succeed at the task, but the dialogues have very different shape. So what we observe is that using our this architecture, which I believe is more beta motivated, we achieve dialogues that are more linguistically diverse in terms of lexical diversity and question diversity, where the interactions are also less repetitive because, I mean, these agents are very primitive, right? Forgot to say that, but that should be obvious. So sometimes what happens is that the agent just keeps repeating questions. So at the level of, for instance, repetitions, the dialogues are also less repetitive. And then when we look at the strategy in terms of the type of questions that are being asked in the course of the dialogue, we also see that this new setup and this new architecture and learning setup also makes an agent that follows a strategy that is more human-like, right? So yeah, so these are the results that we have at the moment. But besides the particular results, we are also trying to make the point here that we should develop measures that look beyond task success when we are working with task-oriented dialogue, right? So let's work with task-oriented dialogues, but let's also look at the dialogues and go beyond task success. All right, so this has been an example of current work but looking at the agent level, right? And I told you that I also would like to give you a little bit of a glimpse of other work that looks not at one-to-one interactions, but at how language is used in interaction, but at the level of communities of speakers. Yeah. So I would like to move into this now. So what are we doing here? In this case, we are focusing on lexical meaning, right? So the meaning of words. This has been our focus here, right? And what we are looking at is trying to capture and tracking the meaning of words, lexical meaning, as it is developed within communities of speakers, right? So not just looking at the general language, if you want, but at how it is, how language is shaped when speakers interact more closely in particular social communities. Right? So within sociolinguistics, this is often called communities of practice. So individuals that are engaged into some common interests. Right? So how do we do this? Basically here we are just using distributed representations, basically word embeddings, but not just to try to achieve, again, some extra points on a particular NLP task, but to try to study some questions that are of linguistic interest. So how can we do this? So usually when we talk about word embeddings, right, when we use word embeddings, distributed representations of words, we tend to create generic word vectors, right? We take the corpus should be as large as possible to derive our embedding model, and this is a kind of representation, a general conceptual representation of what the word means, right? But we can also derive embedding models for different communities, for example, right? Of course, for different domains, right? But also for different communities of speakers. And this, if we do this, then we can compare these word meaning representations and study semantic variation at these kind of levels. And this is in part what we have been doing. So in one particular work, together with Marco Del Tradici, who's sitting over there, we have modeled the language in communities by using, in this case, data from Reddit, from the Reddit website, where you have different subreddit communities, right? So this allows us to access to have a notion of community, right? And then for each of these communities, we can derive an embedding model, just using, in this case, a version of the skipgram model per community, and using some joint parameterization so that then we can compare the word embeddings across different communities. So this kind of looking at language embeddings per community has allowed us to distinguish and to observe how different types of meaning shift that can occur, right? So there is meaning shift that can occur, for example, at the level of a domain, but we are also interested in meaning shift that can occur at the level of a community, right? So for example, you take the word box, right? So here we may have a few communities that are related to the domain of football, for example, right? And we can observe that sometimes we know, of course, words are polysemous, there may be different senses, and often in NLP we find that senses are related to different domains, right? So that's a common aspect. So indeed, if we analyze semantic shift in semantic space, then we can see that the meanings that belong to a domain for a particular word like box are apart, separated from the more generic meaning that we obtain if we use a more general corpus, right? So this is a type of meaning shift that we are more familiar with. But there are other types of meaning shifts that we have observed here that are more at the level of a community, that come presumably from the agents in that community interacting and developing particular meaning conventions. So here you would have another example, right? So apparently, I think that this is for the fans of Manchester United, if I'm not wrong here, right? So within the domain of football, not all the communities just have the same set of meanings, right? So apparently, in the community of Manchester United fans, they use the word theater to refer to their stadium, right? And this is a convention that just has developed within this particular community. Okay? And other communities that may be in the same domain actually just use this word in a way that is more similar to the general use of this word. Right? So this allows us to observe meaning shifts that are present at different types of levels. Okay? So with this work, we have analyzed, for example, what are the linguistic factors that come together with this type of semantic variation, with this type of more socially driven semantic variation, for example, how disseminated the word is in the community and other types of linguistic factors. And we've also have observed that for words where there is a strong shift, a strong community shift, if you are not aware of this shift, then this may have an impact on NLP tasks, like, for example, on a language modeling task, right? So it seems important to keep track of this type of semantic shifts. Okay, so this was semantic shifts at the level of different communities of speakers that interact more closely with each other. Another line that can be also investigated with this type of methods is looking at variation, but variation across time, right? So where we have semantic shift that differs given in the time point where we are possibly within the same community, right? So tracking semantic shift over time is a topic that has become rather popular in computational linguistics in the last few years. There have been a few models where you just slice the corpus in different time periods and then create a model for each of these time periods and then compare the meaning representations for a particular word across these time periods. And this allows you to track the change in meaning, right? So, for example, this is an example from a few years ago, where the word of the meaning of a word is tracked over the course of a century, right? And you can see here that for some words the meaning changes because the similarity between the meaning of that word over the different time periods differs, and for some others it just stays constant. Okay. So using this type of methodology, we have recently been looking at how these meanings how meaning change may occur at the level of particular communities and over very short periods of time, right? So we know that interaction indeed shapes language, and that often there may be meaning modulations that actually happen in the time course of a dialogue, right? We are not looking at this here. We are looking at slightly longer periods of a couple of years, but the idea is to see whether there are changes that may happen very rapidly and whether the current models that we have at hand actually can capture this, right? So this is work also with Marco, but also with Gemma here, she's been coordinating this. And at the moment, what we are finding is that indeed there are changes that occur very rapidly, right? That there are conventions that can be adopted quickly within communities, within social communities. And our question is, do current methods actually capture this type of phenomenon? And well, I will not give you the details, but we are seeing interesting things here, and they do capture it to some extent, but there are also some types of phenomenon that are not well captured by current methods. I will not say more about this. This brings me to the end of my talk. And I just want to recap by saying that I've tried to give you a little bit of a glimpse of some of my current work in two types of line related to language interaction. On the one hand, modeling agents as they interact one-to-one, using end-to-end methods and trying to use task-oriented dialogue, but not looking only at the success. And on the other hand, looking at interaction in a more global sense on how speakers shape language by interacting with each other in small social communities. I'd like to thank my members of my team and my different collaborators that have played a role in this work, and also let you know that I will be hiring some people in the coming year for my ERC grant, so just stay tuned, please. Thank you.
Yeah, so in the example with modeling of the community-specific interpretations, that disambiguation that you do, I'm just curious what you do, how you set things up to avoid complete forgetting of the other uses that those words have, which of course may be statistically infrequent, but will inevitably probably show up. Have you thought about that at all?
Okay, so how we capture, so in the community, all right, so for example, if we find in the community that theater has this faraway meaning, but theater may also be used in some occasions as the more common meaning, right? Well, in the current modeling that we have, we are not really tracking this because the embedding models that we have only give us one vector per form, right? So like it's common. So in that sense, we are not capturing polysemy beyond that, right?
Yeah, no, so the question is, how would you do that?
Yeah. I'm not sure how I would do that, but yeah, you need a model that keeps several meaning representations at the same time that are linked in some way, right? Yeah, I'm not sure how I would do that, but you should arrive to that. I mean, definitely it's needed. I don't know if, Marco, do you have some good suggestion for it? Yeah, I mean, I don't know, Laura, if you have a suggestion. I know that we all know it is a problem, right? So, yeah, so I don't have a good solution, but of course you would like to have this fine-grained representation of things, yes.
Still not working. Ah, no, it's working. Well, an idea it would be maybe to have some representation that is more sensitive to the context in which the word is found, and instead of like having several discrete representations of the same word, that it's always a problem because then you have to decide of many of them. You still have one that you can update depending on the context. So even if some meaning like the one of theater is very infrequent, still it can be retrieved by looking at the context in which the word is. So this is something that we were just discussing, but it's not something concrete. It's not a concrete idea that we have.
Okay, we'll think more about it.
Yes, hello. This is Bruce Hopkins from Zontisa Smart Technology. We're in the process of developing a question engine, and when I saw that you had here a question agent, I'm curious about how you are developing that. You said one of the issues was the repetition of the questions. One of the issues that we are trying to solve is to allow an agent to read a document and then to try to generate intelligent questions from the author in order to get clarification. So I'm just curious, can you talk more about your agent?
But intelligent questions from the author? I'm not sure.
In other words, reading a sentence and to generate a dynamic question based upon what is in the sentence and to ask something that does not appear that it is an agent dynamically. So I'm curious, can you talk more about how does your agent work? What some of the issues that you have run into?
So, I mean, the agent here is driven by a particular task, right? So the questions that the agent generates, in principle, should help the agent to identify a particular object, right? So there is a specific task that gives rise to the questions. So in your case, of course, this can be done in that depends on what your aims are, right? But if you want to compare my setup to what you are saying, you would need to have some sort of motivation that drives the kind of questions, because presumably given a document or a sentence, there is a large range of possible questions that can arise, some questions under discussion that may be available, right? You may want to guide this given the particular task at hand, right? What would be the most relevant questions? So in our case, the questions are really driven by the particular goal of the agent, which is identifying a referent.
So my follow-up question is, are those questions dynamic from your agent, or is this someone who has already predefined?
So the questions are really generated word by word, but of course this is trained on a large data set, this guess what data set, that contains human questions. But it's not a retrieval system that would just pick up the most likely question given a set of already available questions, right? So the agent is trained on the human data, on the questions that the humans have generated, but then is able to generate new questions that may not have been in the training data, and it generates them word by word, right?
Perfect, thank you.
So we need to move on to the next speaker. Thanks, Dr. Fernandez.
Thank you.